This section, I would like to share with you categorical variable encoding. When you work on machine learning algorithms, the input variables have to be numerical. So any categorical variables, you need to convert them or encode into numbers. Categorical encoding refers to replacing the category strings by a numerical representation. Objectives of categorical variable encoding is to produce variables that can be used to train machine learning model. And it is also to build predictive features from categories. Common encoding and categorical variables techniques would be dummy variable encoding, one-hot encoding. This example is dummy variables encoding. The color column has 3 labels: red, blue, and yellow. The number of dummy variables will be 3 minus 1, 2. So now the color column, whereby there are 3 labels, is now being replaced by 2 new columns. So red color is encoded as 1, 0. Blue color is encoded as 0, 1. And the yellow color is encoded as 0, 0. Another type of categorical variable encoding is one-hot encoding. What is one-hot encoding? One-hot encoding is used to convert categorical variables into a format that can be readily used by machine learning algorithms. And the basic idea of one-hot encoding is to create new variables that take on values 0 and 1 to represent the original categorical values. So below example, the original color column has 3 labels or 3 values: red, blue, and yellow. This is being replaced with 3 new columns. So red now is represented as 1, 0, 0. Blue is encoded as 0, 1, 0. Yellow is encoded as 0, 0, 1. So every value would have a value 1. When to use one-hot encoding and dummy encoding, both types of encoding can be used to encode ordinal and nominal categorical variables. Dummy variable encoding is typically used in data analysis. One-hot encoding is used in automated tools such as Azure, Machine Learning, Studio, or Python library. Is more widely used. Advantages of dummy encoding over one-hot encoding. Dummy encoding adds fewer dummy variables than one-hot encoding. And dummy encoding removes a duplicate category each categorical variable. And this avoids the dummy variable trap. You may ask yourself, why don't we use label variable encoding? So what exactly is label variable encoding? Label encoding refers to converting the labels into a numeric form so as to convert them into machine-readable form. So suppose we have a column weight in some data set. So the weights, you have values of heavy weight, average weight, light weight. You apply label encoding, and the weight column is converted into heavy weight is 0, average weight is converted to 1, and light weight is converted into 2. So by looking at this, you think, oh, the light weight of 2 has higher priority than the heavy weight, whereby the value is 0. But this is not true. There are some limitations for label encoding. Label encoding assigns a unique number starting from 0 to each class of data. It leads to the generation of priority issues in the training data sets. And a label with a high value may consider to have a higher priority than one with a lower value. But this is not true, as there is no such priority relation between the weights. For this section, you learn categorical variable encoding, whereby you can have dummy variable encoding, one-hot encoding, and label encoding. Thank you. I'd like to summarize what you learned in topic 2. In topic 2, you learn what is EDA, why need to know the shape of the chart, steps for EDA, understand that there are different types of variables, know how to explore and draw the different types of charts. You also know what is feature engineering, importance of feature engineering, missing data imputation techniques, and also categorical variable encoding. Here are some of the references, some textbook you can refer to, and thank you very much for listening.